while we're just waiting for people to join, Jack and I will just introduce ourselves. So I'm James Belding, CEO of Tokenized. So we're building a smart contracting platform on BSV, and we've been building for quite a few years now and been sort of BSV OGs, believers in Satoshi's vision, and die hard all in. It's the only DLT we support. And so we kind of look at smart contracts in a very serious, holistic fashion. And we're really looking to move all the private markets and all the financial contracts and instruments associated with them onto BSV.
Hi, and my name's Jack. I work as a senior strategy manager at nChain, although my background is in R&D, so I worked in the R&D department at nChain for nearly 5 years. And now I kind of focus on the commercial side of bringing the IP to life. So yeah, we're focused on building on the ideas that we developed in the R&D team at nChain and putting those in products and helping those get out into the BSV world for people to use. So yeah, that's me.
I guess it's also worth mentioning we're both on the TSC, so the Technical Standards Committee for the Bitcoin Association. And I feel like we don't get enough branding and recognition or marketing out there, so it's worth just saying a few things on it. Basically, our mission is to help foster or facilitate the creation of standards for the ecosystem or the industry more generally. And the role is really about taking an unbiased, uninterested position to bring people together that might be competitive with each other or might not naturally align themselves to work together. But these standards we think are really critical because interoperability is really at the heart of Bitcoin. So you'll have to forgive how this looks. There's going to be a little bar at the top. Oh, whoops. But we're actually going to show you the code literally. So the purpose of this is really to kind of take you on a tour of technical resources for building on BSV. And so we're actually going to show you a bunch of standards, resources, implementations, and we'll take you to their website. We'll actually show you the code, show you the resources, and then we'll provide some information afterwards that can help you find these websites and resources that we're going to be speaking about. So yeah, the purpose is to basically get you guys familiar with what's available and kind of give you some context and help you navigate it. I think Jack and I have both been in the space enough time and have been building and using different things that we can kind of help you with stressing quality, importance, how it's used, where it's used, and how it might be useful to your projects. So yeah, standards are key. So we just 3 separate sections: standards, implementations, protocols, and services. So those are pretty self-explanatory. So the agenda is intro to BSV, standards and protocols, key implementations, services for developers, and then a Q&A session at the end. So BSV blockchain is the original protocol, or Bitcoin protocol, and we aim to deliver on Satoshi's vision, quite simply. So the key mantra behind it is, as the massive scale proof of work, a protocol that's really flexible and extensible, so is in alignment with the original intention, so script being unrestricted, and for the actual protocol itself to be stable over long periods of time, so that when you're building on it, it doesn't change under you and cause tons of extra work and miscommunications between different parties. So it's really thought of as more like an IP, a very base level, very simple protocol. It's not simple, but very foundational protocol for a lot to be built on top of it. So it needs to remain very stable. And it's really designed for business. So the ethos around BSV and the vision of Satoshi's vision is very business oriented. It's a very meritocratic vision. And it's all about just providing utility. That's at the heart of it. So a lot of other blockchains, to contrast that, have sort of ambitions that sort of maybe veer into the political realm, and they're looking at sort of transforming things into digital gold and other kinds of properties. And they don't really think about the utility that it provides to businesses and institutions and people. And that's where I think Bitcoin SV really stands out, is it really gets back to, why is this useful? Why do people want to pay for it? Why is it going to be around in 20, 30, 50 years? And of course, there's developers. All those little ideas I think are very important if you're going to build a project on it, even if it's a hobby, something that's stable and going to be around for a long time. And the people that are operating the actual network are making money from it long term, then it's going to be around for a long time. So we'll get into standards and protocols. So the first one is the BSV Wiki. So I know some of the people that worked on this, and they did a pretty good job, I think. So basically, this really looks at the Bitcoin protocol itself and the Bitcoin network, the system, and how it works, the key ideas behind it, the actual mechanics of it, like the technical details, what transactions are, all the different methods and technical ideas. So this is a really good place to start to get your head around BSV. Bitcoin has a similar wiki, but it's veered away from the original vision. And so there's a lot of changes that have been put into it since then. So it's really important to kind of get your grounding or your come here first if you're thinking about building BSV and really make sure you understand the differences and how it works very concretely. So I'll just click on a few pages here and so I refer to this. So I don't refer to it as much these days, but I refer to it quite a bit in the early days. And prior to that, I referred to the original Bitcoin wiki, which is now sort of a BTC wiki. I think it's very, very useful. And it's a good starting place. If you have questions, you can come here, find the key ideas. And then if you need to expand upon it, you can go find people in chat groups and dive a little deeper. But it's a really, really good summary and quite comprehensive. So Mappy, so this is merchant API. This is basically an API service that miners offer to allow merchants and wallets and all kinds of Bitcoin clients the ability to submit a transaction and then know if it's been accepted by the miners, know if it's been rejected. You can get fee quotes for transaction fees. There's a bunch of other details around it. It's in use today. A lot of people use it. It became the dominant standard for a long time. There's actually a new standard that's come out recently called ARC that I think is still practically in beta. There's still some issues being worked out and they're kind of slowly rolling out. I think a lot of the ecosystem will move over to it, but in the short term, this is probably your best bet. So let's click on this. So just straight to the repo. And I believe this was developed by nChain originally for use of the whole ecosystem.
James, maybe I think we can't see your browser at the minute if you're clicking on the link. Just
oh, okay. Like shared it really quickly. Let me just try again. Sorry, that was a bit of a fail. Apologies. So this is the repo for merchant API. So the Mappy does depend on a node, so it's always is a service that sits on top of it. Diagrams, and there's some implementations. I think we'll cover on the implementations down the line. So fee quote. This concept actually changes in ARC, so this is something to be aware of. And the ARC technical specs are available, which we can share later. All right, I'll move on to the next one. So Paymail is becoming the standard for sort of really discovery and human readable addresses. So it sort of masks, it's an alias for the complexity of Bitcoin wallets, which are now done with addresses and locking scripts that are very, very technically complex and vary quite a bit, especially when you veer outside of the normal pay to public key hash. So what this does is it kind of acts like an email address so that you can give it to people over text, or you can have it on a card, or you can share it in a human readable way. It's pretty resilient to making mistakes. And ultimately it gives an identifier to wallets. When you're creating relationships within the wallets, you can kind of quickly refer to who you're sending to and remember who they are, rather than just looking at numbers that or an address that just really means nothing. You can't really remember it. And this is really important when you think about where things going, where wallets go when they have to do privacy preserving algorithms in terms of how they structure a transaction. So it's not as simple as one input and one output, one address sending to another address. It gets a lot more complicated pretty quickly to kind of preserve privacy and make sure that who's transferring to who and what they're transferring is actually masked and not in the public domain. So these kind of protocols or these standards become really, really important. Tokenized uses it. We really like it. There's some other things coming in the pipeline that I think are going to improve it from a security point of view. But basically all the important BSV wallets at the moment, the ones that have significant traction, use it. And so it's a widely accepted standard. It's probably the most widely used standard in the whole ecosystem at the moment. And so this is actually, the link here is the Technical Standards Committee library, the paymail standard itself in the library. So this has been published. So it's gone through the entire process that we put it through in terms of drafting, getting work groups together, critiquing it, reviewing it, and then we did a public review, and then eventually published it once everyone's happy with it. So this is quite a useful spec, and it's quite stable. So there's a little acknowledgements and details here. And down later in the presentation, the webinar, we have an implementation that you can go to and look at as well. So really the best way to think about this is like email style addressing for Bitcoin wallets. It can be extended to a lot more. So over to you, Jack.
Thanks, James. And yeah, this is one that's very close to my heart. So the MetaNet protocol is an example of a kind of layer 2 overlay protocol for managing data on BSV. And there are lots and lots of different examples of protocols that do things like this. There's the Bitcoin attestation protocol. There's many, many more with specs that you can find out there. And this is just one I wanted to talk about because this one is something that I worked on creating a number of years ago and can be used in a kind of generic way. So the idea of this protocol is for data structure, and you can add other protocols on top of that for maybe how you encrypt data, how you sign data, basically whatever you want to do with the data you put on the blockchain. So if we click on this link, you will take us to part of the BSV Wiki, actually, which talks about the protocol definition. So this will take you through what the actual node and edge structure is. There's this diagram here that explains how you structure transactions together, how they're linked together using signatures, for example. And then back in the main page, you kind of have you see the transaction definition of what fields are required in a transaction for it to be a MetaNet protocol. And this is a good example of what you have in BSV in terms of data protocols, where you have different ways of interpreting the on-chain data. So you can specify a layer 2 rule set, like this rule set we have here, that will apply to a Bitcoin transaction. Now, the miners don't necessarily care about these rules. They won't be checking if your transaction is valid based on them. But as a layer 2 user, as an application developer, you're then applying a different rule set to those transactions. So yeah, there are lots of similar specifications for other protocols out there. And this is an example of how you can of the kind of thing you can expect when you develop on BSV, which kind of protocols you can use. And we'll come back to that a little bit later, actually, with the envelope specification. So what is the envelope spec then? This is given that we have lots of these specific individual data protocols, the envelope specification is an attempt by the Technical Standards Committee to provide a way for them to work together. And again, they don't need to use the envelope spec to work together, but this is a way we can have multiple protocols applied to the same data item. So if we click on this link, will take us to the TSC website this time. So this part of the BSV website. And again, similar to the paymail spec, this has all the same details, has all the explanation of how the standard was developed, the motivation and background, problem statement. And really, this is an example of showing developer need for data protocol interoperability, right? So we want these individual data protocols like MetaNet, like Bitcoin attestation protocol, and all the other independent Bitcoin and BSV data protocols that have been developed in the past. So we want them to be able to work together, and this specification explains how you can effectively pipe them along together and use them to apply to the same transaction. So I definitely recommend looking at this one because this also highlights a few different protocols. For example, encryption protocols, different methods for encrypting the data on chain in a secure way. So this not only will show you how protocols can work together, but also explains a few specific ones as well. So yeah, back to you, James, for the next slide.
Yeah, so peer channels is all about really bringing the peer-to-peer interactions, the vision of it into practice. So peer channels are basically services that wallets can operate. So it can be service to service, it can be service to client, it can be client to client, and these can include miner services as well. So this could be kind of client to the mining network as well, nodes. So this is something we actually use as part of Tokenized. We have peer channels. So when we create relationships, like it's a concept that we have in terms of like you create a wallet, you want to add contacts or other businesses and wallets that you want to interact with regularly. We create these things called relationships. And underneath that, we use SPV channels or peer channels, sorry, is the new name, to basically facilitate that communication. And you can create different peer channels for each service, each client. It's ready for IPv6. I don't believe our implementation offers that yet, but it's the protocol itself is ready. I'll just take you on some. So yeah, this is the repo. So we built our own reference implementation that we're actually using in production as well now, or just about to push forward. And so really like another way of thinking about this is kind of like a stripped down, more efficient Bitcoin specific like mail system, like an email system. So it's really tailored to the needs of Bitcoin and transactions and different records around it, even like tokenized messages and things like that. And there's a lot of cool features with it. And it also, the service and protocol will allow for if the other client or receiving connection is offline, it will keep sending it and make sure it gets it when it comes back online. So there's a lot of features there that are important. And this is sort of like the high level view on the bsvblockchain.org website. So it kind of talks about this is one of the key ideas behind the network itself that's coming out. So ARC is another piece of the puzzle, peer channels, PayMail. These are really key sort of technical concepts that have, protocols and implementations underneath them. But these are sort of how the whole thing is starting to get to put together. So this is an important one to learn about. The basics. So we'll look at implementations now. Is this you, Jack, or is this me?
I think this is still you until this script.
Okay, thanks. All right, so the Bitcoin SV node. So this is the node that currently all the Bitcoin miners are operating on, and some overlay networks services that use it as well. So this is sort of based on the original Bitcoin node software. It doesn't have the features that BTC added in later on, like SegWit. So this is like an original sort of going back to the original version of Bitcoin a long time ago, but it also sort of has elements of BCH when that was in there. So there's a bit of a history there, but this is currently what everything's operating on. It's probably a good place to start to learn about like Bitcoin and how it actually works, the code, the policies, some of the methods. And importantly on this one, there's a new version of this effectively going to supplant it in the future called Terranode. So rather than trying to fix this old software that still works good, but does have some limitations when it comes to real extreme scaling, they've elected to kind of rewrite it from scratch. So that's what Terranode is. It's the same protocol as Bitcoin, and it takes the lessons learned from this node, and they're going to basically expand it out, make sure that it can scale very easily, and it's flexible in terms of its scaling. And it's just more performant in a lot of ways, and then sort of actually connects better with some of the overlay services. So ARC and MAPI kind of examples of that. So that is just tighter integration, more performant, more reliable, this transaction kind of submittance, acceptance, all the communication with the miners becomes more robust. So that's kind of the future. But this is what we're operating on now, and for the next year, I would guess at this point, is this is the main workhorse. So this is the node repo. So still chipping away at it. I think they do little updates here and there. But there's a rich history in this. And even the BTC node, going back, looking at the original changes and things like that is useful if you're interested in those kind of things. You can go look at the comments and pull requests and see the discussions and things like that around it, as well as like forums that give context to it. But I found it very interesting, and it's cool to see how it developed and the debates that took place and why things were done. So tokenized protocol. So this is our protocol, but it's open source. So you've got a license that's permissive. Anyone can use it for free without any licensing issues. It's really a smart contracting protocol, but most people sort of think of these things in terms of tokens, and tokens are definitely a key feature within the smart contracting protocol. So it is definitely a token protocol as well. And so this is in our repo specification. So the specification actually defines the protocol, and you can build your own implementations. So we have a bunch of open source implementations that you can use to spin up and start issuing tokens and operating smart contracts and trading and things like that. If you're just using a basic wallet to interact with these tokenized protocol tokens, it's quite simple to do the basic functions like transfers and basic commands, basic actions. If you want to get into really sophisticated full contract functionality for complicated instruments, it's quite complicated, and there's a lot of work on the wallet side as well as like platform sides, depending on your approach. But we've got a lot of different languages and a lot of documentation, and it really goes through all this. There's also a transaction builder for it. And so this helps you build, it's in Go, but it helps you build all the transactions with the tokenized protocol, encoding and decoding and all the features in it. There's also, if you go to our website, tokenized.com, there's a docs for the protocol, and that really dives into our thinking and philosophy behind it and explanations for how everything works and fits together. So that's another resource that's we put a lot of effort into. So Bitcoin Reader is kind of like a light node. It basically, it's not even like a full node. It really just lets you read all of the traffic online. So it reads the network, Bitcoin node network, and you can see all the transactions coming in. You can process those transactions as they come in, and you can decide if you want to keep them or discard them. But it really lets you basically just read the Bitcoin network or the transaction stream. So this is done by Curtis. It's a tool we use internally. We just released it open source for anyone to use because it's not that valuable from a company perspective, and we thought it would help a lot of people. And I think a few other companies are using it now, and a few hobbyists as well.
Okay, thanks, James. So I'm going to talk a little bit about Scrypt here, which is a really interesting example of implementation, because this is bridging the gap between normal Bitcoin development, and Bitcoin development is not an easy thing because it uses quite a low level language that's similar to Forth, if you've ever used Forth as a programming language. So it's a script based language, dot codes, and it's not easy to work with if you want to do very complex things, if you're just working directly with it. But what we have with Scrypt is essentially a high level language structure, and now a fully fledged framework for how to develop smart contracts using Bitcoin script. So it allows you to write effectively things that look much more like Ethereum type smart contracts and are much more familiar in form, look a bit more like JavaScript and TypeScript. But under the hood, this will then compile down to Bitcoin script that you can add to your Bitcoin transactions and put on the blockchain. So if we can take a quick look, because this is incredibly well documented. So I'd highly recommend you spend some time to go through these docs. It explains in particular, the theory here about how Bitcoin smart contracts work. So what is the model of smart contracting on Bitcoin? Because again, we have the UTXO model in Bitcoin. It's different to the account model of Ethereum. So there's a different approach to it. And then there are a bunch of tutorials as well. So yeah, if we look at one of these, it walks you through, okay, once you understand the basic idea, then how do I actually write contracts using script? So again, you can see this looks very much similar to how you'd write TypeScript. It's meant to be compatible with it. So you can then go and write scripts to perform various different functions, to embed different constraints into your Bitcoin outputs and unlocking scripts that allow you to do various different things like time locking, auction, Oracle, for example. Even zero knowledge proofs is a really interesting one, and voting. And this also allows you to interact with some of the data protocols I mentioned before. So, we've looked at protocols and standards on BSV, and this library is one of the ones that, and framework that this is something that can help you interact with those, create transactions for them. And if you need to get some example code for writing your Bitcoin script, then there is also a repository that has a whole bunch of boilerplate and example implementations for different examples. So I can see ordinals here, a CLI interface. You also have things like Rabin signatures here. So if you want to implement a new signature scheme on top of the base blockchain, then you can, which is really useful for verifying data in script, which is a really cool use case for doing things like oracles and auctions. So yeah, I highly recommend spending a lot of time to look at script, because this is going to make it a lot easier for you to start developing on BSV. And in that vein, so we also have a number of, if you're not so interested in doing really complex scripts, and instead you just want to be building transactions as fast as possible, then there are a few different libraries. So we'll talk through a couple of them. The first I'd like to talk about is TX-Forge here. So this is, again, a fairly high-level library that essentially helps you build transactions. It has all the kind of expected functions, things like UTXO management. So if you scroll down a little bit, you'll see kind of some of the basic features you have in TX-Forge. So you're able to, here we go, managing UTXOs, creating a transaction based on the UTXOs that you've defined earlier, and things like that. So this is kind of a bread and butter library that you'll like to use in BSV. And the next one I want to show you is actually the kind of lower level underpinning library. So TX-Forge is built upon this library, Nimble, and this is more of an all-purpose JavaScript library for BSV. So the TX-Forge builds upon this to make transaction building easier. If you want to be a bit more low level and customize things yourself, maybe do a bit more interesting things in terms of private key management and how you associate keys with your transactions and store them securely, then this is potentially more for you. So this is, again, this is something you can use using as a standard node package, and then integrate that into your applications, write in a familiar language using JavaScript. And this will help you, again, handle your transaction, handle your private keys securely. And basically, whenever you want to integrate BSV into your web application, this should help you do that. So the next one I want to talk about after this is actually, okay, well, if you're not a JavaScript user, and if like me, you prefer to use something like Python, then again, we have a BSV lib, which is a Python implementation of virtually pretty much all the same things, and has a lot of the standard functionality that you'd expect. So things like key management, digital signatures, standard script types like pay to public key hash, pay to public key, multisig, and things like this. And also integrations with APIs. So I know the What's on Chain API you can see is integrated with this. So this is a library I've actually used a lot myself for research purposes, for testing out new ideas. And I know Python is incredibly popular now, especially if you're interested in the data side of blockchain and looking at different transactions. Maybe you want to look at which protocols are being used and which ones are more frequently used. So if you're a Python user, then this is kind of the equivalent of Nimble or other BSV libraries out there for JavaScript. So again, recommend looking at this one if that's your preference. And then we also have, so we mentioned earlier, in terms of standards, we have the envelope specification. James, I don't know if you want to talk us through the because you will have developed this, but we do have this really great implementation that goes with that standard for the envelope spec.
Yeah, so this is probably the one of the only actual implementations, as far as I'm aware, that's really being used in production. I think people are playing with it. I don't know a few companies, but I'm not sure if anyone's really using it, apart from maybe Handcash with some tokenized stuff. But this is our actual implementation. It's fully open source. Curtis, who's on our team, is actually one that kind of came up with the envelope system, at least the initial idea, and authored the original proposal, and then obviously had the rest of the TSE work group help him and really had a lot of valuable input. But this is his baby. He's really been thinking about this for a long time, and it really suits our usage quite well. But yeah, basically the idea of envelope is just to kind of allow for data that's stored within a transaction to be made sense of, so that other services and things like that can quickly parse it, understand it. They can understand what kind of encryption is being used, what the different fields are, what type of encoding is being used. And it's very, very flexible. So there's a lot of really cool features that have been put into this that make it very, very useful, and sort of a really good base for an interoperable on-chain data envelope.
Awesome, thanks, James. So just to finish off, then we're going to talk about services, right? So we've gone through protocols and standards, so kind of universal things. Then we've looked at some implementations that you can leverage as a developer to get going with development, and then now we have services. So these are even higher level. What things can you just take advantage of to improve your applications and use? And the first one is an obvious one. It was what's on chain. So this is the block explorer. Really of choice in BSV is something that I use every day, many times a day. So what's on chain, in addition to being a block explorer in the sense that you can go and look at the latest transactions and blocks on the blockchain, it also has a bunch of these features, right? So you can broadcast transactions directly from the browser if you want to start testing something, if you want a quick way to check if a transaction is valid or you've created a script correctly, for example, you can go and broadcast it on what's on chain and see if it works. So if you're just interested in looking at real live blockchain data, then you can just go through here using a very familiar interface that is used by many block explorers. But then you also have access to all these other things as well. So you can look at which node they're using, and you can also access the API of what's on chain, which is something I also personally use a lot for research purposes, but also can be used if when I'm looking at data from the blockchain, you can also use it for submitting data as well. So again, what's on chain is an incredible resource. I would look through all of these different tools you have, because you also have some summary of the mempool, for example, and stats on different tokens that are being used. So the mempool summary is telling you, okay, what kind of fee rate can I expect as a developer? And that can help you manage your cost. You can forecast, how much is it going to cost to make X number of transactions or to make scripts of a certain size. We also have some stats on the tools page as well on what's on chain. So if we go back to the tools, then you can see on the stats on the left here, you can see which applications are being used, and also just general blockchain stats as well. So yeah, there's lots to explore. As I think it's growing all the time. Every time I go back, there's more to explore. So I would get familiar with what's on chain, and as James showed, definitely go through the API documentation to see if there's something there that you can use, whether it's pulling data on the blockchain state, or you're more interested in actually interacting with the blockchain and sending data. Okay, and then in a similar vein, so Tal, which is one of the key miners in the space, also has a platform that you can use, an API suite with various different services. So again, very closely linked to what's on chain. And this is just to show you, so you can log in to the platform, and you can create an account on Tal, and this will help you manage API keys for accessing these various services. And then I won't log in now and show you. It's very easy to go and get an account. But the really interesting thing is when you go and look at the public documentation for Tal. So you can see on the left, you have a bunch of different core products, one of them being a wallet, one of them being an SDK for a token protocol, the STAS protocol. There's a token service API, which helps you manage tokens more easily as a command line interface for submitting. So yeah, just looking at the token service API for a moment, this one can basically help you manage all the transactions associated with a given token. And again, you can manage your API keys for this API using the Tal platform. So again, I won't go through all the detail on these because there's almost too much to talk about in the Tile platform. But if you want to just have an easy way to interact with the blockchain, and this is more the submit side, so if you have transactions you need to get on chain, then I would highly recommend looking at the Tile platform as the easiest way to do it and getting started. And there are a bunch of free trial programs for that as well. Then in terms of Bitcoin analytics, so we already have what's on chain as a way of looking at some of the statistics, but if we go to bsvdata.com, this actually gives us a much more application to application breakdown of what's happening. So in addition to kind of the basic statistics you get on what's on chain, you also get identification of which applications are creating the most transactions. And one thing I want to note here is this is really your view from an analytics perspective of the data protocols we mentioned before, because when we look at transactions on the blockchain, we identify them as one of these applications on the left based on the structure of the data in the BSV transaction. So if they follow let's say a certi hash transaction, if we see a transaction that follows a certain script pattern, then that's how we identify it as a certi hash. So there's a real connection between the protocols and standards we talked about earlier, and now the analytics side, where you're reading the data from the blockchain instead of writing it, and you're trying to look at what's going on. So yeah, this is a really good resource. Again, one that I use all the time for which protocols are being used on the blockchain. It also has various different analytics similar to what's on chain. But if you want a quick look at how your application is doing, how it compares to usage of other applications, and you kind of want to use it as a proof point for success, then this is also a really good thing for you to use. Then we have Jungle Bus. So this is a slightly different, not so analytics side, but one of the big things you need to do if you're building a high throughput application in particular is you need to have a low-level indexing system for that blockchain data. So you don't want to be just querying the blockchain every time you need a transaction and asking a node, for example, for all the data, or maintaining a full copy of the blockchain yourself and then having to scan through all of that data to find something. So Jungle Bus is an API service that's been created by Gorilla Pool, so one of the key miners in BSV, and this is performing the function of indexing data based on different criteria, so that effectively you can manage subsets of the data stored on the blockchain for you to query for your application. So if you have an application that relies on a certain script pattern or a certain type of transaction, for example, and again, as we saw with BSV Data's analytics, most applications are doing something slightly different to each other and something specific. So if you need to manage a specific transaction type and you need to pull that data from the blockchain in a timely manner, then the Gorilla Pool Jungle Bus API is a really good way of doing that and indexing that data so that you don't have to write this yourself. Now, of course, you could write an indexer yourself, and there are other indexes available, but Gorilla Pool's one that I know lots of people in the space are already using. So if you're a new developer to BSV and you're thinking, how do I get started? Then that's why we kind of recommend looking at Gorilla Pool and the Jungle Bus API, because it should be very easy for you to get started with this. Then we also have BitTails. So this is quite similar to some of the implementations we showed before, but this is kind of more of a service. So if we click on this one to look at the documentation, this is a really nice API interface and service for doing lots of the same things as you can do with your Python JavaScript libraries, but as an API interface instead. So things like managing addresses and transactions, checking block and mempool data, checking network statistics, for example. So this is kind of combining some of the features of your block explorers, like what's on chain, with some of the features of your lower level libraries, like your BSV lib for Python or Nimble for JavaScript. So I just thought this is a really nice one to highlight, because if you want a bit of a one-stop shop for application development, then BitTails is a really handy one, and as you can see here, has a really nicely documented API interface. Then we also have Handcash Connect. So I'm sure many of you, if you've been in BSV for any real time, then you'll be aware of Handcash as a really great wallet that many people use. And there's a reason why Handcash is connected to so many of the successful applications in BSV, And that's because they offer the Handcash Connect API and SDK, which makes it very, very easy for applications to embed or to integrate with Handcash payments. So if we scroll down, for example, you see some examples at the bottom here. So Haste Arcade, Dogs, Tonic Pow, all of these are very successful applications that also live, they live separately from Handcash, but they can also be accessed from Handcash's kind of application gallery. But the key thing is that all of these applications are connected with Handcash for payments. So when you go into these applications, once you've connected your wallet as a user, then you can easily make payments on the platform. You can make micropayments and do all these kind of Web3 use cases that we're interested in. So the Handcash Connect SDK is how you can connect with Handcash. If you're a developer and you've got a great idea for a new game or a new kind of consumer-facing application that you think is going to be really cool, but it needs payments and you don't want to build a wallet and you don't want to build all the payments infrastructure from scratch, then the best way to do it, I think, right now is to look at maybe integrating with the Handcash Connect SDK, because this is a very successful path for many people. And finally, from me, so we also have Relesia, which is similarly kind of a one-stop shop in terms of API and SDK. So if we look at the documentation for Relesia, they also are highly successful in supporting many, many different applications on BSV. So again, I would just recommend looking at their documentation. They offer a suite of APIs, SDKs, as well as wallet management and dashboard. So if you need to manage wallets, they also have great educational content. So if you're developing in BSV, this will have everything you need to get started. And again, if you log in, if you create an account there, then you will get access to all the resources. And there's a number of different products and services. I wanted to highlight the API and SDK suite for Relesia, but they also have other products and services for more mature applications that need slightly different things. So maybe that's data management or managed services for applications that maybe you don't want to focus on doing some of those things yourselves, and they've been in the space doing that for a long time. So again, Relesia is something as a resource I would say to look into, has various different things you might end up using as a BSV developer.
All right. So yeah, Tokenized. This is I'm the CEO of this one. So this is our smart contract platform as a service. So we're sort of more of a platform and wallet, and so we have a desktop app and a mobile app, and it really aims to kind of make the user experience for real issuers of financial instruments and their investors, the holders and counterparties, and all of the sort of associated people involved in those transactions. So we create something that's really, we hope, is a very useful experience for them and easy to use, but kind of allows for all the benefits of having these much more digitized, much more automated contracts across the life cycle on chain with that immutable data layer. So we have not only a desktop app and a mobile app where they actually work together. So the mobile app is really where the wallet is, and it does all the signing and the key management, and it never shares with the desktop, never shares it with our platform. And then the desktop app is really about managing all of the data, preparing transactions, proposals, and communicating with the other people involved and viewing contracts and things like that. The platform also lets you access or the developer side of things. This is the protocol I was mentioning before. These are protocol docs. So these go through things like philosophy, the contract structure, the contracts and data structures, how they all link, the different operations. So governance operations, transfer operations, instrument operations, all these ones, there's actions within these operations, and they all sort of sum up to create a very comprehensive set of methods to basically manage transactions across the life cycle, including amendments and governance and voting resolutions being proposed and cast and exercising rights and fulfilling obligations. So it's really takes the whole idea of contracts and tries to structure it and standardize it even to some very extremely complicated contracts like derivative instruments and very complicated debt instruments or convertible instruments. We sort of tackle all those. A key idea is that rather than sort of more of like a low-level, flexible, smart contracting language like Ethereum uses or script uses, which we would argue isn't actually a good term for it. Smart contracts are not really what they are. We take actual terms and conditions that are in contracts and we codify them. So I'll show you an example of that. So I'll do a basic one right now. So currency. So currency is like a central bank digital currency. So issued by a monetary authority or central bank. And we got some fields that are specific to it. And then we got share commons. So this is not the final version. This is just a public version right now. But you start to get into things like collateral, par value, interest payments. Some of these are enforceable by the smart contract. Others are enforceable at the wallet level or the platform level. And some of them are meant for like being an insight that you can keep track of and remind you of certain things. Other things are basically automatically enforceable. But I won't go too in the weeds there because there's a lot to talk about. We've also got an SDK and an API. So because of the nature of a wallet with self-custodial, it's very, very tricky to actually connect directly to the API and build a compelling wallet. It is fully doable. Our API is open, and you can definitely create your own wallets. But we highly recommend using the SDK, and it just takes out all the pain. So you can create an app very, very quickly, interacting with all these complex features and being interoperable with everything else if you use that SDK. And it took a really, really long time to do it. I can't stress that enough. Everyone comes in thinking they can just hit the API, but it's super, super complicated when you start dealing with all the different states. Like if you're proposing a trade, like an atomic swap, and you got multiple signers on both ends, and you have rejection options and acceptance, but blocking actions. There's all these kind of complexities in terms of the actual organizations coming to an agreement and executing that trade. We kind of make it all very, very easy. And the SDK is very non-technical in the sense that you don't need Bitcoin expertise. You just need to be a JavaScript developer to be able to use it. So this is all terms that are fairly business friendly and traditional. So you won't be exposed to the Bitcoin specific language and terminology and concepts. The keys are hidden from you. All the address management, UTXO management is hidden from you. And I'll just quickly show you what the API reference looks like as well. So you got quick start, all the release notes, authentication, logging in. So entities and profiles. So again, I don't think for most people, unless you're really hardcore and you want to have a crack at it, this is more of like an internal facing API. So it really connects to our desktop app and to our SDK. And it's if you really want to have a play with this and start using this, we recommend using the SDK, or you can actually even use the desktop app. So we make the entire front end of our product. Our platform is fully open source, MIT license. So you can actually just take our desktop app and tweak it and delete things and modify it to suit your use cases, effectively whitelist it, or you can use the SDK. But having said that, sometimes it's nice to go into the API and just kind of understand how it all works, the mechanics behind it. Excuse me. Oops. And so I think we'll open it up for questions now. I'll probably just stop sharing my screen. So if anyone has any questions about anything for me or Jack, please just share them in the chat box.
Looks like, yeah, we do have one here. So we have a question: where does BRFC implementations come into the whole ecosystem, as it's not part of the official TSC? Plus, where do we go to track the latest developments into the IPv6 integration and SDKs related to this? I don't know if you want to field that one, James.
You can go for that, Jack.
Yeah, well, so we have the BRFCs are kind of a formal, as I understand it, they're a formal way of writing down a proposal and managing how that's named and identified. So they're kind of a separate thing to TSCs, but lots of TSCs actually build upon them or are linked to them and reference them. So there's kind of a relationship between some of them, but you can have BRFCs that exist outside of technical standards committees. So there's kind of a potential connection between them, but not always, is my understanding.
They could also go through the TSC at a later stage when people decide they want to use them as well. So that process can be like a more formal work group process to actually suggest, review, modify them, and then have the TSC sort of publish them. In terms of the IPv6, I can't comment on that. Do you know anything about that, Jack? The last part of the question.
Yeah, I think the question, so asking about latest developments, where can we track latest developments with IPv6 integration and SDKs? So I think the best place to watch for that is on the Bitcoin Association website, BSV blockchain website, because that, I think that is all part of their internal programs and how they're developing the software. As far as I'm aware, there's not a technical standard in flight in the TSC that's related to IPv6, and if there's demand for one, I think that'd be a really interesting one to have. Another place, so speaking from nChain, is that's something we are working on is how we use IPv6. So papers coming from R&D in nChain is a good place to look at how we can integrate blockchain and IPv6 in the future. But in terms of official roadmap things for BSV itself, yeah, I think just BSV blockchain website and any press releases from there or blogs and things coming out is the best way.
I think it's also, as far as I understand it, the Terranode team are really working on making sure they're compatible with IPv6 and taking advantage of it with respect to not only Terranode, but the services around it, the overlay services. So they're probably in a big way kind of pushing things forward and kind of making sure everything works together and is future-proof for IPv6.
Yeah, exactly.
So I got another question here from Angus. Are there plans to put all of this in a single place or a single place that lists all the reference implementations? So the recording of this webinar is going to be published, and I believe we're going to be putting all the different links that we've shared in this webinar under the video, so you can be able to go click them and find them easily. And I hope we'll also be able to share the slide deck as well, in case that's helpful to anyone reviewing it. But then separate to that, we've also got the TSC library that's currently exists, but is also being developed actively and is going to get better and better with time. And the idea is that all of these sort of reference implementations and standards, even things that didn't go through the TSC, will be available as a central repository to collect and for developers to come as sort of the main resource for them to use it and find things. And we'll have sort of mechanisms for if we're missing things, people can submit suggestions and we can curate it a little bit to make it as useful as possible, add context and links.
Awesome. We have another question from Andres, so asking about what's the difference, which is a really interesting one actually. What's the difference between Scrypt directly to develop tokens or using Tokenized to develop tokens? So I'm sure you can answer this one, James, but maybe I'll just give my take on it first. So as far as I'm aware, Scrypt, the fundamental difference being Scrypt is a general purpose high level language. So I think it's much more like what Solidity is for Ethereum, whereas Tokenized is first and foremost is a protocol, but it's also an implementation and a product for developing tokens in a very specific way. So with Scrypt, you could go and implement many different token schemes. You could build your own token scheme from scratch with its own specification with Scrypt because it's just like a programming language. Whereas with Tokenized, you're building to a very specific, determined specification that James and team have developed over a very long time.
Yeah, and we use Scrypt ourselves for Tokenized. Like the Tokenized protocol fully leverages all locking scripts or the full flexibility script, and we can use Scrypt to help manage complex locking scripts that our tokens are effectively held at, and authorization logic and scripts are used for managing contracts and many things like that. So they're you can definitely create other protocols on top of Scrypt that are token, and there's lots of flexibility there, but it's not really a token protocol by default. You have to do a lot more work, and there's other services and elements to it that are important. So I think let's see. Is there a TS that is describing at least one smart contract protocol supported by TSC? If not, do you plan to make kind of standard for newbies to start with? What's the TS stand for? Is there
a technical standard, I think?
Oh, okay, sorry. Yeah, it's good for a technical standards committee member to. So I don't think the technical standard committee is planning on making an opinion or having an opinion or formalizing any token protocol anytime soon. I think the position is generally want to be seen as, when we're in the TSC with our hats on, we want to be neutral and we want to let the market kind of decide over time, and then eventually we might roll something in like that. So I think for the moment, all of this token standards and smart contract protocols, you go to their respective docs as the source of truth, which are evolving and very complex anyways. It probably doesn't fit that well into a technical standard, which is very narrow in scope and really focused on specific mechanics. Some of these protocols are, so many methods and data structures and elements that I don't know if it would necessarily fit in there, but maybe in the future.
Yeah, one thing I would comment on here as well is that when you're saying the questioner is asking about describing a smart contract protocol, so what James has said is talking about, like token protocols being one class of smart contracts or smart contract protocols. Because in BSV we have a flexible scripting language where you can write anything. Virtually any script you write, you could consider a smart contract in various ways, and there are different ways you can different levels to which you can take this. You can do quite simple contracts, which are something like pay to public key hash, where you're just moving funds to a new key.
Okay.
Or you can do much more complex things like adding time locks, as we're seeing with hod locker and things like that, right? Which is using some kind of advanced functionalities. So a good resource for like learning about the basic script types or the basic smart contract types you can do, like multi-signature, pay to public key hash. That's all things that you can find on the BSV wiki, and how you write scripts to achieve different things. And then in script documentation, you do have examples of different types of smart contract. So I wouldn't say there's a protocol for doing smart contracts in general, but there are smart contract examples that you can lean on.
Yeah, apologies. I'll add to that as well. Sorry, I misunderstood the question. So this is why I'm so precise in my language when I call what a smart contract is and what a script is, because it is very confusing. And I will add that Vitalik even regretted publicly calling contracts what they do in their protocol contracts as they're not, right? So I think script is the best way to think about it. And so what you're referring to, I believe, is a script template. And there's definitely actually in the plans for the TSC to eventually compile a list of common script templates. And also miners, I believe, are going to start to put together script templates and have fees that are specific to those. So some script templates will be free. And so these kind of lists will start to compile. And I think that's largely going to be based on, communicating with the market and wallets. What script templates do you need? Why do you use them? And then also just data on chain. What are they seeing a lot of, and what's the kind of reasoning behind it? So I think those kind of things are coming, and the TSC, I think is well positioned to kind of have a resource to collect those and be a good resource for users.
Okay, well, it looks like we've either answered all the questions or made too many for people to say right now, but yeah, it looks like that's probably a good place to wrap up if we haven't got any more questions. So yeah, thank you all for joining us. Thanks for listening, and bye from me. If you have any other questions, obviously, please feel free to reach out to us via various social channels or get in touch directly with the Technical Standards Committee or the BSV Blockchain Association as well. There you can find the contact details on website. So yeah, that's all from me. James, I don't know if you want to say any closing words.
No, thanks for attending. Like you said, I'm really active in the MetaNet Slack if anyone's in there, and I'm also active in our Telegram for Tokenized if you want to just reach out to me specifically. But yeah, there's also the main channels through TSC and things as well. So thanks everyone.
Thank you.